Today we're going to be exploring sound waves. I want to remind us that we are marine scientists and we are helping the superintendent at the Stellwagen Bank National Marine Sanctuary. I want to remind us also that we are investigating how animals communicate across the distance, and those animals that we are investigating and trying to figure out are the bottlenose dolphins. So we know that sometimes the mother dolphin gets separated from her calves, and so we're trying to figure out how do they communicate with each other so that they can find each other in such a large body of water. Here's our big question: how do animals communicate across the distance? Through the investigating that we've already done and some of the text that we've read, we know that many animals communicate using sound waves, and we know that a wave is a pattern of motion that travels away from a source. So the pattern of motion doesn't travel towards the source, it travels away from the source, and we'll do a little review of that too with the diagram today. So we have a lot in store. I want to go over the vocabulary, but we do have some text to read, and you guys will have the opportunity to work in a sim to actually see how sound waves work to get that investigating done as well. So let's go ahead into our key vocabulary for today. We have two new words. We have energy. What is the definition of energy? Energy means the ability to make things move or change. This definition we actually have we should be aware of, because when we were engineers, this is one of our definitions at that time as well. New vocabulary word for us is visualize. What does visualize mean? Visualize means to make a picture in your mind. So we're going to visualize some things today, and we're also going to talk about some sound energy today. Before we get into our text, I want to quickly go over our classwork and our objective for today. So here's our classwork. This is what you're going to see. And as soon as you watch your instructional video, this is what you're going to complete today. So as usual, you have your book, you have your sim. This is going to give you access to the simulation for today. Our objective for today, I will be able to explain how sound gets from one place to another. The simulation is greatly going to help you with that, as well as the text warning tsunami. I'm noticing that as we write our definitions in our PDN, we're writing definitions that we either Googled or are coming up with ourselves. Please make sure you are using the vocabulary words that are always going to be in blue in your classwork. These definitions are going to keep us on the same page and making sure that we have the same definition as I go through the lesson. When I say the definition, it'll be familiar to you. So please don't make up a definition or Google a definition, but be sure to use the definitions that are provided for you in your heading. You have your PDN as usual. And then this worksheet we'll come back to later is actually what you're going to fill out as you explore your simulation for today. So we'll come back to that later. Thinking about warning tsunami, I want to do a quick review because the last time we read this text, we learned that the tsunami wave pattern is up and down, and we also learned that the source of the wave is an earthquake. So we know that an earthquake actually has to happen in order for a tsunami to happen. In that earthquake, we know the seafloor is actually going to break, causing those waves to get very large and to become a little dangerous. So today we're going to read more of the warning. Today we're going to read more of warning tsunami to help us understand what moves in a wave. So we know how the wave moves. We know that it moves up and down. But now we're actually going to read pages 13 and 14 to help us understand, well, what is actually moving in that wave? Is it water or is it something else? So let's go ahead and get into our text. So in your text, you want to turn to page 13. That's where I'm going to go. I am already there for the sake of time. So I am going to read through page 13. We will read page 14, and then we will also visualize the diagram that is on pages 14 and 15. Remembering as I read the text, you should have pencil and paper next to you so that you are able to jot down any notes or any key information, because we want to be the best marine scientists that we can be. So you want to make sure you are jotting down key information so that when we have to communicate with the superintendent, we know exactly what we're talking about. Let's go ahead and get started. So we have this illustration at the top, and reading the caption, it says people ran from the tsunami that hit Hawaii in 1946. It was caused by an earthquake that happened near Alaska. And so that's going to play a little role actually in how water, in what moves in these waves, because it's not actually going to be water. But tsunamis can be very dangerous for the people who live on the shore right there. Let's go ahead and get into the text. What moves in a tsunami? An earthquake near Alaska can cause a tsunami that devastates Hawaii, about 4,600 kilometers, almost 3,000 miles away. However, that doesn't mean that water from Alaska travels all the way to Hawaii. The water itself is hardly even moving in a tsunami. If it was, imagine all of the ocean animals living in the water near Alaska that would get swept across the ocean and land on the beach in Hawaii. So my question to you is, if the water is hardly moving, right? That's what we just read in the text. The water itself is hardly even moving in a tsunami. If the water is hardly moving, as the tsunami waves move across the ocean, then what do you think could be traveling in that water? Right? So if this water is not actually moving as we think it is, what's actually traveling through this water to make these waves the way they are? And the answer we're going to actually find on page 14. So I'm going to go ahead and flip the page, but that is something that I want us to think about. What's actually moving in that water as those waves move? Page 14. It's not the water that travels across the ocean in a tsunami. All that travels is the energy of the wave. Now, I feel like that's my answer, right? So if I remember the question actually being what's moving in that water as the waves move, they're telling me the answer right here. So it says, it's not the water that travels across the ocean. So it's not the water that travels from Alaska to Hawaii. All that travels in that wave is actually energy. So it's a lot of energy that's traveling that's causing those waves to move the way they are moving. When the earthquake in Alaska makes the seafloor move, the moving seafloor disturbs the water on top of it. Then that water disturbs the water close to it. The water close to it disturbs water a little farther along, and so on for thousands of miles. The up and down movement travels like a relay race across the ocean. All ocean waves behave like this. It's the energy of the wave that travels, not the water. So when we're thinking of the tsunami happening and we're thinking that, oh man, this water must be moving from the ocean near Alaska to the ocean near Hawaii, well, actually, no. It's not water and sea animals moving from one place to another. It is actually the energy that is moving through those waves. And so now I want us to think about the diagram that's on pages 14 and 15. And I want us to look at this diagram and I want us to visualize what's actually happening here. And when we think about our definition, visualize, we see that that means to make a picture in your mind. So this is when you're sort of using your imagination, because we know that this water is not actually moving, but I want you to visualize it in your head and in your mind. I want you to think about the energy that's moving through these waves and that's actually causing things to get damaged, right? Because the energy is so strong. How does the energy get strong? How does it become a tsunami? We know that the earthquake has to happen and it has to break the seafloor. That is the source of the tsunami wave. And so that's something that we also need to remember. So I'm visualizing it. I hope that you're visualizing it. We want to visualize again this energy flowing through those waves. Now, based on the investigating that we've already done, and we've sort of already been investigating waves, and we found out that energy can travel in those waves, just like we just read. I want us to remember something about energy, and I want us to make these connections, right? We know something about sound energy. Yes, we know something about sound energy. Now we are going to sort of translate that into understanding sound waves. So sound energy, sound waves, very similar, but now that we're thinking of water and we're thinking of how dolphins are communicating with each other, we need to investigate sound waves. And to investigate the sound waves, we're actually going to use our simulation to help us with that. So where do sound waves come from? Well, sound waves come from the sound of music. It comes from the sound of our voices. It comes from the dolphins communicating with each other. We heard those dolphin calls, and so we know that those dolphin calls also create sound waves. So let's go ahead and I'm going to quickly walk you through how you're going to get to that simulation. In your classwork, you have your link. Your link is here. When you get to the Amplify page, we're no longer in Earth's features. You actually want to go to Waves, Energy, and Information, which are bottlenose dolphins right here. You're going to click that, and then according to the directions here, you're going to click the orange number 1, which is titled Sound Waves. Once you click that, you actually have your simulation right here. So you have these little guys. I'm not going to say what they are because you need to mention that in your classwork today. You have these little guys. You have your wavelength here. So if you have your line, you're able to see the wavelength. I suggest you keep that on. I also suggest you keep the volume on because you're going to need to hear the different instruments. Now, 2 ways you can maneuver through your instruments. You can maneuver through the arrows, and you can actually click the view all sounds, and you can go ahead and click which instrument you like to test out. So for the sake of this example, I'm going to go ahead and test out the drum, and then I'm going to test out the flute. So this is what you're going to see once you test it out. Now I chose the flute. I'm going to play it. Noticing the pattern that's coming from the flute. What is the source of that pattern? What is the source of that sound wave? It is the flute. Now I'm going to go ahead and change it to the drum, and we're going to notice a difference. So noticing this wavelength has a different pattern than the wavelength of the flute, and these are the things that you're going to actually need to notice as you complete your assignment today. So when we look at the assignment, you have some observations that you're going to need to make. In the second column, you're going to record what you notice about the simulation. So what do you see moving, right? When you see the patterns, what do you notice? When you hear the sound, what do you notice? The source of the sound, you need to give me that as well. What you notice goes in this second column. Now, there are going to be lots of questions, and I know if we were in class, I would see a lot of hands asking, Miss Adams, what is that? What are these orange things? Why are they moving? Why are they there? What's that green line? Why is the green line there? What's happening in this, right? You have all those questions, and I don't want those questions to go away. I want them to go right here in this column. What I wonder. You're going to type in what you wonder every time you see a pattern, every time you hear a sound. When you think about the source, you're going to type in what you wonder. If you wondered that the drum would sound differently, type that in right here and let me know, and I'm going to look forward to reading all of your information. You want to give me your best, highest quality work, so make sure you're not just giving me one word, you guys. Give me a lot of information because this is a very exciting simulation, and I want to know all of your thoughts, and I want to know everything that you notice as you go through all of the instruments, okay? All right, that is the classwork that you will have for today, including that PDN. Don't forget your exit ticket. Some of you have been forgetting that exit ticket. You have classwork and an exit ticket to complete and turn in, okay? Let's go ahead and get back to it. So that's what you're going to do for that simulation. Now, when I think about the simulation, I want to think about that in real time. So we saw the simulation, we saw these little guys moving, we heard the sound that it made, we see the pattern, but how does that work in real life? And so if you've ever gone to a show or something and you had people on the stage, well, the sound waves are going to come to your ear because it's very similar to this diagram. It's going to start from the source and make its way to you in very much the same way the sound waves are moving in that simulation. I want us to quickly think about the diagram here and how energy moves away from the source. Remembering the source is the hand, we have the slinky, and we have the rope, and the energy is moving away from the source in those waves. Key takeaways for today. Many animals communicate using sound waves, right? Sound energy